Okay, so now we're going to be building the emitter follower circuit that we're using as a variable speed motor control. What we have here is the voltage divider that we used earlier toward the end of lab 1, where we take 6 volts and we divide that between a cadmium sulfide cell and a resistor. And when you have strong light shining on the cadmium sulfide cell, it has a small resistance, and so you have a high value of voltage here. And then when there's darkness around the CDS cell, this resistor becomes very high, and this voltage then drops down. Now what we found at the end of lab 1 is when we hooked up a motor directly to this, the very low resistance of the motor loaded down this resistor, and this voltage divider failed to work. But what we're doing now is we're putting a transistor in between the motor and the voltage divider here. And the transistor will be in the active region, and so that we'll have a current that's being supplied through the collector down to the motor. And what we'll have as a result is that the voltage right here is directly following the voltage here, but the current for the motor is being supplied down through the collector. And this is described in the accompanying notes. So we're going to go ahead and build this. We're using the TIP31C transistor. That transistor is an important one to use because the motor, as we know, can take up to a couple of amps of current. And so a small transistor won't be able to supply the current that we need, but this larger, heftier one will be able to. When I build these, I like to always redraw the terminals of the transistor, base, collector, and the emitter, because they are different from transistor to transistor. So by having that drawn there, I know what the pin-out arrangement is. Okay, so let's start building. I'm going to take my cadmium sulfide cell, and I'll first just connect that between 6 volts and this terminal here. You can see that I've actually trimmed the leads on this CDS cell. Those leads are kind of thin, and they sort of bend quite a bit, so I just trim them a little bit with a. You could use a scissors. I happen to use a wire cutter. Okay, then we had our 10K resistor that goes to ground. So this node here is the same as this node here. And now what we want to do is connect that node to the base of the transistor. So we've got the transistor in there. Sometimes you have to force it in. Okay, I'm going to use I'll use a green wire here. I'm using neither red, orange, nor black blue. I tend to use red orange when I'm connecting something directly to the positive voltage rail, and I would use black blue when I'm connecting to ground. Here I'm using green, because this can be either a high or a low value. So that's going to go into the base. And then what we need to do is ground the emitter. So it's base, collector, emitter. So the emitter, we're going to ground that using a black wire. Of course, the circuit doesn't know what color wire you're using, but you'll know when you try to debug it. And when you ask someone for help, they'll say, okay, black wire, that's connected to ground. A green wire, that's connected it's not connected to either ground or the voltage rail, positive voltage rail. Okay, now I need to connect my motor, and the motor is going to be connected between the collector and 6 volts. So I'm going to start out with a red wire. I'm going to need to use the alligator clips to connect to the motor. Okay, we're on one of the leads of the motor. And then I'll use the black alligator clip. And I have to connect that to the collector of the transistor. And that's the pin in the middle because it's base collector emitter. Okay, I'm about to apply power to this now. And if all is hooked up correctly, and if the circuit's designed correctly, what I should have is that the motor speed will vary as I change the amount of light on the CDS cell. Okay? If I cover it completely, you can hear that the motor is off. And then if I put a lot of light on it, it's back on. And then I have quite a bit of light from the room, but let's see if I can make it go even faster with a flashlight. Not much. I'll put off the overhead light. Okay, so now it's clearly off and you can't see anything, but I'll slowly approach the CDS cell. Okay, so that is our variable speed emitter follower motor control circuit.